Okay, let's talk about section 11.2, the parabola. In the last two videos, we discussed lines and circles. Now let's talk about another geometric object. It's called parabola. First, let's see the definition. What is a parabola? We always say that the quadratic equation has the graph as a parabola, but what, what this word parabola really means here. This is a definition. A parabola is a collection means set, is a collection of all points P in the plane that are the same distance d from a fixed point f as they are from a fixed line d. Okay, so this is the definition of a parabola. Let's visualize it. So we have a fixed point, we call it f, and we have a fixed line, whatever position, a fixed line, we call it d. And then you're looking for a point, for example, this point, this is P. You measure the distance between F and P, and you measure the distance between point P and the line. This distance, you just draw the perpendicular segment. Okay? We require this segment and this segment have the same distance. Then this P is on the parabola. And P could be here, P possibly could be here. You just move this P, satisfy this condition. The distance PF is equal to the distance from P to D. And you continue this. These two segments have the same distance. Well, of course, when you move this point P, these two segments will have different, will have a length. Here is longer, here is shorter. We don't care this distance is longer, this concrete value. We just care these two segments must be the same. For example, at this point, you see you measure the distance, and you connect these point P and F. You see, of course, this is longer than this one. After you move that, this distance is longer than this. It doesn't matter. We just require here and here they have the same distance. Okay? And you continue this. Possibly we just estimate. The distance between point P and the and this fixed line is always constructed by projecting this P to this fixed line. This is always right angle, and the distance FP, you just connect them. Okay, and these two segments have the same distance, and then you connect those, so you just collect them, and here's symmetrically you will get a parabola, and this whole collection is called a parabola. The collection of all points with this property, it's a parabola. Okay, and this fixed point F is called the focus, and this line D is called the directrix. Directrix, my bad. Directrix. That's why we use the letter D. Directrix. Okay. So that's the geometric definition for the parabola. And you can see that if you have a point in this direction, And symmetrically, you will have a similar point here. It has the same distance to F and the same distance to D. So it's definitely symmetric. It's definitely symmetric about this axis. All right, and there's a midpoint. When you project this F to D, and you choose a midpoint, midpoint definitely guarantee that this segment is equal to this segment, and this is called the vertex. The midpoint between F and the line D is called the vertex. And this parabola will be symmetric about this vertex. This right side, left side, they are symmetric. All right? Okay, so that's the geometry. So we already discussed the geometry. Now let's try to see the algebra. We want to see the algebra, which means we are looking for the equation. So first part, we're trying to find the equation. Find the equation of a parabola. Find the equation of the problem. Okay? Okay, so if we really place vertices here randomly and directrix like this in whatever slope, it's very difficult for us to find the equation, or the equation will be very messy. So we're trying to see the special placement. So here is a setting. So we're going to place the focus, this F, on the x-axis, positive direction. And we say the focus has x-coordinate A, y-coordinate 0. This is the focus. And symmetrically, we are going to place this directrix at negative A. When we say symmetric, we mean with respect to this y-axis. One is on the right side, the other one is on the left side. One has a coordinate A, the other one has a coordinate negative A. This is directrix. Okay, this one is on the setting. We are going to find the equation of the parabola with the focus at A, 0. The point is A, 0. And the directrix, what is directrix? Is x equal to negative A. We're looking for this, the equation of this parabola. It's very specially placed. Okay. Okay. So assume that P has a coordinate x, y is a point on this parabola. Okay. Assume we have a point. Let's assume this is point P. Then how do we satisfy the parabola condition? Parabola means the distance PF, the distance P and F is equal to the distance between P and D. This is a line, remember. Because this one is vertical, if you go perpendicular to the vertical line, it's horizontal, so this is a horizontal. Right, this is horizontal. Okay, so this is a geometric condition. We need to use this condition to find the equation. You have a point x, y. You have a point A0. What is the distance? dPF is square root of x minus x coordinate square, y minus y coordinate square. This is the distance between P and F. Then what is the distance between P and directrix? Remember, this is a horizontal. It's horizontal. For the horizontal distance, it's always the difference of x. Difference of x coordinates. You see, this is a x coordinate. This is negative A. You use x to subtract the negative A. it's always a difference of x coordinate if it's horizontal. If it's a vertical, it's a difference of y coordinate. Vertical, it's a difference of y coordinate, like different level. Horizontal distance is difference of x coordinate, right subtract left, right subtract left. X minus negative a is x plus a. Well, this is the simplified version, but by the definition, it's always subtraction. Okay, so this distance is equal to this distance. So we have this one, x minus a square plus y minus 0 is y. Y square is equal to x plus a. That's an equation. If we don't require or if we don't do any further step, then this one will be the equation. Okay, but this equation looks, well, not simple, right? So we want to simplify it. We're going to simplify it. How do we simplify it? Here you have square root. Here there's nothing. So we're going to square two sides. Square it. If we square it, basically we're going to cancel this square root. The left hand side becomes x minus a plus y squared. You cancel square root. Right hand side, there's nothing, so you just square it. X plus a squared. So we square two sides, we get this one. And then let's continue simplification. X minus a quantity squared is x squared minus 2ax and plus a squared. And plus y squared is equal to the right hand side. You expanded this perfect square. X squared plus 2ax and plus a squared. Right? We just expand the perfect squares. And you see x squared on two sides, they are cancelled. A squared on two sides, they are cancelled. Right? And then you have negative 2ax. We move negative 2ax to the right side. It becomes positive 2x. With this positive 2ax, it becomes 4ax. You see? It's much, much better. So this is the equation of the problem. So let's write down it. So the equation, we can call it a theorem because we did several steps computation to find it. The equation of a parabola with focus at A0 and the directrix x equal to negative a. Of course, here we require a positive, this setting, is y squared equal to 4ax. Y squared is equal to 4ax. You see? Very, very, very simple. Okay? Very good. So this is our equation you are going to memorize. And if we really sketch it, it will be like this. It's open to the right. It's open to the right. It's this one. This parabola has the equation y squared is equal to 4ax. Y squared is 4ax. Okay, one more thing. In this part, if we get, remember we have a vertex. How do we get a vertex? We start from focus and do projection to the directrix. Here you have vertex, you have focus, you direct it to the, you project it to the directrix. This is A. Here's A, so this segment is A, this segment is A. So the vertex is the origin. So this here, the vertex is the origin. 0, 0. Well, x is 0, y is 0. So this is the vertex. We put vertex as the origin, focus A0, directrix x equal to negative a. Be careful, this is a line. This is line equation. It's not a value, it's a line equation. X equal to a value. It's a line equation. X equal to negative a is a line equation, okay? I repeated several times. Focus, directrix, focus, vertex, directrix. That's the order. Focus, vertex, directrix. Focus, vertex, directrix. All right. So it means whenever your value satisfy this equation, x, y, the coordinates satisfy the equation, it will be on the parabola. It will satisfy the condition. The distance between the point and the focus is equal to the distance between the point and the directrix. Okay? So we know that 0, 0 is on the parabola, is on the parabola. It's a vertex on the parabola. Let's see another special one. When x is equal to a, remember a is positive. X equal to a, then what we have? We have y squared is equal to 4a times a, 4a squared. 4a squared is 2 times a quantity squared. Remember, y squared is equal to 2 times a, the product squared. Then we take square root. We will get, remember, whenever you take square root, you will have 2 square roots. One is a positive, the other one is negative. If you do not have any condition. Okay, so what does this mean? This means when x equal to a, you see here, you project it up. You get this point. This point has coordinate 2a. This is a positive 2a. And of course, you can move down, you get this one. This one has a corresponding y coordinate, negative 2a. Negative 2a. That's all. Another thing we can really find it out. Other value, if you put like a 1, 2, 3, you will get a certain square root, which is not easy to evaluate. Here we can evaluate, so we just lift them out. Okay, so here's negative 2a, here's positive 2a. So this whole segment has length 2a minus negative 2a is 4a. Okay, so this whole vertical segment from top point to this bottom point is has a length 4a. So we say that the vertical line segment joining what? Joining the top one. Top one is a to a. X is a, y is 2a. And the bottom point, a negative 2a. This segment, it has a name. It's called the latus rectum. Latus rectum. Okay, this segment is called a latus rectum. Its length is 4a. You just use 2a to subtract the negative 2a. You will get 4a. Okay, so well, it's a name, a latus rectum. You may see this word, this name in the practice exercise, and when you see them, you just know, okay, you know what it means. That's enough, right? But focus, vertex, directrix are 3 most important concepts. This one, I cannot say it's not important, but it's less important, okay? And the length is 4a. Always keep this in mind. Whenever you have exercise involving this name, you know where you can find. All right? So this setting is always fixed whenever. So the focus, let's see here, focus is A0, A0. Vertex is 0, 0. Directrix is negative, x equal to negative a. Okay, so those 3 elements are tightly related. are tightly. If you know two, you will know the third one. Two of them will determine the third one. Okay, if you know focus is A0, directrix x equal to negative, then the vertex must be 0. Or if you know focus is A0, vertex is 0, 0, then directrix must be x equal to negative. So that's what I say. Two of them will determine the third one. So in other words, actually in this case, we will either just mention focus and directrix, or we mention focus vertex, or we mention vertex directrix. But if we just mention 2, then it means you know 3. Okay, so let's see the first example. Find an equation. Find an equation of the parabola with vertex 0, 0. You see, 0, 0. Vertex is 0, 0, 0. And focus at 3, 0. 3, 0 means A is equal to 3. Okay? And graph it. Okay. So because we know the vertex is 0, 0, focus is A0, 3, 0. So the directrix, this is x, directrix is x equal to negative 3. So that's exactly our setting. This is exactly our setting. And with A equal to 3. A is equal to 3. The equation is, what is the equation? Y squared is 4ax. So it's y squared is 4a 12x. And that's it. That's it. So that's the equation. Y squared is 4ax. Y squared is 4 times 3 times x is 12x. Okay? So you don't do any further computation. You just identify A equal to 3 and use 4 times 3 is 12x. That's the first part. Find the equation. Graph it. How do we graph it? Basically, you're going to do this. You're going to label vertex V. You're going to label focus F. You're going to label the directrix x equal to negative 3. And then you just estimate, you check, possibly this is the parabola. Parabola will be more or less look like this. Okay. Well, we can never be precise, but we just estimate. So this is a parabola. Parabola is open to the right. The parabola is open to the right. And that's it. That's it. Vertex, focus, directrix, and opening. You can never cross it. Okay? All right. So this is our first example. When we know focus and vertex, we can define it. We can write down the equation. Or when we know focus and directrix, we can also write down the equation. So far, we only have one case. We know the equation. Then that's the only possible way. All right. So this is one direction of a problem. We have those geometrical quantity. We want to write down the algebraic equation. What happens if we have algebraic equation? We want to determine the geometry. Okay. Analyze the equation. y squared equal to 8x. Analyze the equation y squared is equal to 8x. Okay, then you check this. This is a y squared equal to 4ax type. So you're going to say it is the equation of a parabola with a equal to 2. That's a 4ax. So 4a is 8, a is 2. Then this is our setting here. The vertex is 0, 0. Our current knowledge just have vertex is 0, 0. The focus is A0, 2, 0. The directrix is x equal to negative 2. X equal to negative 2. This is a vertical line. X equal to negative 2. And that's it. That's all you need to write down for the analysis part. When you have y squared equal to 8x, you should be able to write vertex, focus, directrix, and A. So that's from algebra to geometry. Those are points and the lines, they are the geometry. Okay, so this is our special setting for the study of a parabola. Of course, we have other settings. This is the first one. Let's see other 3 types of settings. Okay, the first one, let me summarize it here. First one, I place the focus on the right side, A, directrix on the left side, x equal to negative A, and I get the equation y squared is equal to 4ax, and it's open to the right, to the positive x, open to the right. That's the first setting. And second, I never say this is a unique way to place a point and the directrix. We can do this one. We can flip it. We put the directrix on the right, A part x equal to A. We put the focus on the left side, negative. And this is vertex. Still the vertex is the origin. And then in this moment, the parabola will be open to the left. The negative x direction. This is positive x. Go to the left is negative x direction. Okay, negative x direction. The equation, we can go through the exact process or almost a similar process like this. I'm not going to do that. I just convince you it is, remember it's a negative x direction, opening. Negative is a negative 4ax. Negative x direction is negative x. Positive x direction is a positive x. Okay, open to the left, negative 4ax. A is always positive. In the whole setting, the letter A is always positive. Okay, so open to the negative x direction is negative 4ax. Open to the positive x direction is a positive 4ax. They are both y squared equal to them. And the other 2 setting will be like this. We can place the directrix vertex vertically. We can also place it horizontally. So for example, we place this focus on top A, it's 0a, and the directrix bottom y equal to negative A. And then the parabola looks like this. parabola looks like this. And the corresponding equation, check here. This is open to the positive x, it's a 4ax. This is open to the positive y, so you will get 4ay. Okay, because here you have y, then this part you have x. X squared is equal to 4ay. Positive y, 4ay. Positive x, 4ax. Negative x, negative 4ax. Okay, so this is x squared is equal to 4ay. The last special place is like this. We're going to flip this situation. This a, the directrix is y equal to a, and focus is negative a, 0 negative a. So it's the opening is open to the negative y. It's open down, it's negative y. In this case, the equation is x squared is equal to negative 4ay, because it's open to the negative y direction, Okay, and all four cases, the vertex is always 0, 0. Vertex never changes in all four cases. We only change the focus and the directrix. Okay, so that's all four standard positions. We need to memorize all four standard positions. And all these formulas, x squared 4ay, x squared negative 4ay, all these four formulas can come from the similar computation like what we just did. Okay, now let's analyze the equation. X squared is equal to negative 12y. Okay, when you have such equation, I recommend you first sketch the graph. You see, how do I know? It's negative y, open down. And directrix is always on the other side of the opposite side of the opening. Focus is always enclosed by this parabola. Okay, so it's always a negative sign is negative sign. 12 is a 4 times 3y, so you know that a is a 3. So this is the equation of a parabola with a equal to 3. A is always positive. The focus is here. You see, it's below the x-axis, so it's a negative 3. It's negative a, so it's a 0, negative 3. It's on the y-axis, so x coordinate is 0. The vertex is 0, 0. Vertex, all four cases, vertex is always 0, 0. The directrix is y equal to 3. This is a 3. It's horizontal, y is equal to 3. Oh, what's going on? Okay, so this is the analysis. So from the equation, you figure out A, and you know it's opening down, and you can determine the focus, vertex, and the directrix. Focus, vertex, and the directrix. All right. And this is from algebra to geometry. Let's see from geometry to algebra. Find the equation of the parabola with focus at 0, 4, the directrix, the line y equal to -4, graph it. Okay, so I do recommend you to graph it first. Okay, so let's check. Focus 0, 4, 1, 2, 3, 4. Focus is 4. Directrix y equal to -4, 1, 2, 3, 4, -4. Okay, so the graph will be like this. Well, just sketch. It does not need to be precise. Okay, so you see from here, you see it's an open up. Open up x squared equal to 4ay. Positive y, 4ay. A, what is A? A is a 4. So the equation is x squared is equal to 4 times 4, 16y squared. That's it. That is the equation. Very simple. Okay. Now let's make this problem a little bit complex. Example. Find the equation of a parabola with vertex at 0, 0 if its axis of symmetry is the x-axis and its graph contains the point -1/2 and 2. Find its focus and the directrix. And graph it. Okay, so it's very long. And first, it does not give us the focus and directrix directly. It only gives us the vertex. So let's try to see it. The important concept is the axis of symmetry. You see, in this, we only have 4 cases. The first 2 cases, the axis of symmetry is x-axis. The last 2 cases, the axis of symmetry are y-axis. Okay, so this condition, its axis of symmetry is x-axis, give us it is either this direction or it's this direction. You either go open to the right or you open to the left. Just 2 choices. Okay, so this sentence gave us 2 choices. And then it says the graph contains -1/2, 2. X is -1/2, y is equal to 2. It contains this point, okay? So when it contains this point, it means only this part is possible. The left branch is possible, the right branch is impossible. So you just get this is what you have. The graph is like this. Graph is like this. It's open to the -x. So let the equation be -4ax. Remember, y squared. -x, -x, and 4a is always 4a. -4ax, -4ay, +4ax, +4ay. They're always there's always 4a there. So it's negative x. Because you have x here, then the other one will be squared. The other letter will be squared. So the equation is y squared equal to negative 4ax. We don't know a. We don't know a. What is a? The graph contains this point. So x is negative 1/2, y is equal to 2. So 2 squared is 4. Negative 4a, x is negative 1/2. Okay, so 4 is negative, negative cancelled. 4 times 1/2 is 2, is 2a. 2a is equal to 4, so a is 2. A is equal to 2. So the equation is y squared is equal to negative 4 times 2, negative 8x. This is the equation. And once you get a, you can determine the focus. The focus, what is focus? Focus here is this is negative 2. Negative a is negative 2. Directrix will be on the other side. X equal to 2. So focus is negative 2, 0. On the x-axis, negative 2, 0. The directrix is x equal to positive 2. One is on the left side, the other one will be on the right side. It's very symmetric. And graph it, we already graph it, it's open to the left. We actually graph it first, and then we can label the corresponding x coordinate and the y coordinate and focus and directrix. Okay, do the graph first and then use the graph to determine other geometric objects.